In this video, I am going to explain about the MPLS traffic engineering semi-dynamic tunnel with exclude option. As you know, we have learned about the explicit traffic engineering tunnel and also dynamic traffic engineering tunnel in previous videos. Now we talk about the semi-dynamic tunnel. This is a thing between actually explicit and dynamic tunnel. Don't forget, you can configure semi-dynamic tunnel with two methods. This is the first method, exclude option. I will explain about the second method in the next video. For example, in this scenario again we have three passes. The first pass, the blue pass, has more bandwidth in compared with two other pass, for example the red pass and also the green pass. Because of that, R1 will send all traffic of these three loopbacks, means these three networks, from the blue pass. Okay, I will show you, and after that I will configure semi-dynamic tunnel. Again, we try to distribute traffic between different links, but in this time we don't configure explicit tunnel. We don't configure dynamic tunnel. Actually, this is semi-dynamic tunnel. For example, exclude means please don't pass from one pass, okay, one specific pass, one specific IP address, and then you can find the next pass. For example, assume that for loopback 1, a network of the router 5, I want to send the traffic from a pass, but this pass should not be blue pass. You can configure exclude option, means don't pass, for example, from router 2, or for the other network, don't pass from another network. Actually, in exclude semi-dynamic tunnel, we say please exclude this IP address from the path you are finding in the network. I will show you, don't worry. As you can see here in the router 1, now if we use show IP route OSPF command, actually the OSPF or IGP chooses the gigabit 00 for the outgoing interface to reach to quad 5/32 and also 5.5.5.50/32 and 192.168.2.545/32. And it is obvious. Why? Because this pass, the blue pass, has the lowest metric. Okay. Now I'm going to configure semi-dynamic tunnel. Don't forget, again here we have the text file, and in the text file step 0 is similar to the previous scenarios. You can use OSPF or ISIS for the IGP, each one that you want you can configure. Here we don't have any difference between the IGP. The first step is IP address configuration and enabling interfaces on router 1 to router 5, and also IGP configuration. Here we don't have any new note. Because of that, I configured it previously. Step 0 is down and you have this configuration. And after that, we need to go to the step 1. Again, step 1, we don't have any new topic because we learned about it in previous videos. Global MPLS traffic engineering or TE configuration on router 1 to router 5. You know that IPsec should enable, and this is by default enabled. Good news. And after that, we need to use this command, MPLS traffic engineering tunnels. This is by default disabled, and it is mandatory to configure this command. And after that, MPLS label range minimum maximum is the recommended optional command that we can use. Okay, for now, let me to copy these configurations to our CLI, because here we don't have any new note, and we learned about this part of configuration in previous scenarios. This is the router 1 configuration, and then router 2's configuration, and after that the next router is the router 3. You can copy and paste the configuration, and also you can type the commands. You know that after configuring the traffic engineering globally in the iOS, we need to enable the TE on the IGP. that can be OSPF or ISIS. The next step, step 2, is IGP MPLS traffic engineering TE configuration. With this command, router OSPF1, MPLS traffic engineering area code 0, MPLS traffic engineering router ID loopback 0. This command is similar on all routers. Because of that, let me to copy the configuration of router 1 and paste it on all routers. Router 2, router 3, router 4, and router 5. And now we need to go to the next step, step 3. Step 2 is done. And step 3, interface MPLS traffic engineering configuration on all routers. Again, here we don't have any new node. Interface range command, MPLS traffic engineering tunnels, and IP RSVP bandwidth. The R1 configuration, this is the R1 configuration. And also in the router 2, in the router 3, and router 4, we have similar commands, as you can see here. And finally, in router 5, again, we have 3 interfaces. Because of that, we need to copy the configuration of router 5 and paste it here. All right. Now we need to configure the most important step in this scenario. Step 4, configure 2 tunnel interfaces on router 1 to router 5. What are the requirements of these tunnels? Tunnel 0. Destination IP should configure as 192.168.2.545. It's okay. And the type of this tunnel is semi-dynamic. This is the first time we see the semi-dynamic tunnel. The bandwidth requirement for this tunnel is 4 megabit per second. As you can see here, only the blue pass and red pass can provide us 4 megabit per second of bandwidth. But the next requirement is that you shouldn't pass from the router 2. What does it mean? Here we have 2 requirements for this tunnel. First, the bandwidth requirement is 4 megabit, and also you shouldn't pass from the router 2. Which pass has this criteria? It is obvious that only the red pass can provide us this criteria. The next tunnel, tunnel 1, destination IP is 192.168.2.545 again. The type is semi-dynamic. The bandwidth requirement is 2 megabit per second, and we shouldn't pass router 2. Actually, about the bandwidth requirement, all paths can provide us 2 megabit per second. And when you configure no R2 means please don't pass from the router 2. It means that you can pass from the red pass and also green pass. But because we use the bandwidth of red pass in the previous tunnel, only the green pass can provide us this amount of bandwidth. You know that when you use 4 megabit per second of this 6 megabit per second, actually, because in newer versions of iOS we can use only 75% of bandwidth. Actually, on 6 megabit per second interface you have only 4.5 remaining bandwidth, and when you use 4 megabit per second of this 4.5 megabit per second, only 500 kilobit per second is remaining, and it means that only green pass can provide us the next 2 megabit per second of bandwidth. And now the question is how we can configure the exclude semi-dynamic tunnel. First, you need to configure explicit pass. Actually, in this explicit pass, we don't configure the pass. We say please don't pass from one specific IP address. Here, for example, the name of our explicit pass is the no R2 IP. You can configure it with identifier or name. Both of them can be used. IP explicit pass name no R2 means please don't pass from the router 2. Okay, this is the name. Exclude address is the router ID of router 2 or the IP address of the interface of router 2. Both of them can be used. Exclude address means please don't pass from the 192.168.2.542. This can be router ID or traffic engineering router ID or IP address of the interface of router 2. And then on the interface tunnel 0, I configured IP unnumbered loopback 0, tunnel destination, tunnel mode, tunnel MPLS traffic engineering bandwidth requirement, and tunnel MPLS traffic engineering pass option 1, explicit name route, then the name of our explicit pass. Don't forget here, actually, it is similar to the configuration of the explicit method. But this is not explicit method. Why? Because in the explicit pass, we didn't configure the actually next stops. We configured please don't pass from this IP address, exclude address. This is semi-dynamic. Why? Because the traffic engineering tunnel should dynamically find the pass, and also this is a little similar to the explicit pass, because we say please don't pass from this IP address, and also we use IP explicit pass command. Because of that we call it semi-dynamic, not totally dynamic, not totally explicit, and this is the semi-dynamic. Also, for the next tunnel, tunnel 1, again IP unnumbered loopback 0, tunnel destination, tunnel mode, tunnel MPLS traffic engineering bandwidth requirement, and finally, tunnel MPLS traffic engineering pass option 1 explicit name, no R2, means please don't pass R2. Okay, and after that, in the router 1, let me to configure IP explicit pass name, then no R2 or any other name. Okay, exclude address 192.168.254.2, and if you want, you can monitor it. Do show IP explicit pass can show us that the name of this explicit pass is no R2, and here we have only exclude address. All right, then interface tunnel 0, IP unnumbered loopback 0, and then tunnel destination is 192.168.254.5. Tunnel mode is MPLS traffic engineering, and then tunnel MPLS traffic engineering bandwidth requirement is 4000, and finally tunnel MPLS traffic engineering then pass option 1 is explicit, and then name is no R2. The tunnel will come up, and we expect to see that this tunnel uses now the red pass. Do show MPLS traffic engineering tunnels. Okay, traffic ENG tunnels. Okay, as you can see, tunnel is up and it uses the router 3, router 5, and it is obvious that it is selected or choose the pass correctly. All right, here you can see pass option 1 type explicit no R2. And also we need to configure the next tunnel, interface tunnel 1, again IP unnumbered loopback 0, and after that tunnel destination is 192.168.254.5, and tunnel mode is MPLS traffic engineering, and tunnel MPLS traffic engineering pass option. For example, first you can configure bandwidth, and then bandwidth 2000 kilobit per second, tunnel MPLS traffic engineering. After that pass option 1, then explicit name no R2. Again the tunnel will come up, and then we can check the result of our configuration. Show MPLS traffic engineering tunnels, tunnel 1, okay, can show us the tunnel 1 now is up, and it uses the router 4 then router 5. Why? Because this is the only pass can provide us both requirement, bandwidth and also exclude address. What is the next step? In the next step, step 5, we need to configure two static routes. Actually, we are steering traffic to the tunnel, to two tunnels with a static method that you learned about it before. And for quad 5/32, please use tunnel 0. For quad 5 or 5.5.5.50/32, please use tunnel 1. As the outgoing interface here, you can see these two commands, IP route commands. Let me to configure them. Here, the command is IP route quad 5, quad 255. Okay, please use tunnel 0. And after that, IP route 5.5.5.50. quad 255, and then tunnel 1. In the routing table, do show IP route static. Now we have these two paths, and we can use trace route command to see the result of our configuration. Trace route quad 5. Okay, we expect to see that this traffic passes from the red pass. Okay, yes, router 3 and then router 5 means red pass. And then trace route 5.5.5.50. Again, as you can see, traffic went to the router 4, then to the router 5. This is the semi-dynamic tunnel with the actually first method, exclude address. In the next video, I will explain about the other option of the semi-dynamic tunnel that actually we can say that is the last option of configuration of pass options. You know that for pass option until now we learned about the explicit method, dynamic method, and semi-dynamic with the exclude option. But we have another method that you will learn about it in the next video. Now it's your time. You need to configure this scenario from scratch, and after that please come with me to the next video that I will explain about the next method of configuration of semi-dynamic tunnel.